So here's a project that I'd like to talk a little bit about today. This is going to be a canopy over an entranceway into some apartment complex, small apartment complex here in a local town. There was a couple things that I would like to go over. You can see it's bow shaped. It's made out of 16 gauge, 1 inch square tube. And there are 3 interesting parts of this that I'd like to talk about. The first is this part that covers the top. This is stainless, and the underside of this is has the protective coating on it. So after we install it, and we'll peel that off, and it'll be a nice mirror finish on the bottom. And that was cut out on the plasma cutter, and I'm going to talk about how we did that, because we had to index that because it's bigger than what will fit on my little 4x4 plasma cutter. The other is this particular part here. It's going to have some PVC letters put on top of it that says South Cedar. But you notice the number of holes, and as you're pretty familiar with plasma cutters, you know that sometimes, especially in these small holes, it doesn't do a real good job of making them nice and circular, and those needed to be pretty accurate diameters, 1/4 inch diameters. And so I'll talk about how we had to modify that. The rest of the letters, all of these were obviously cut out on the plasma cutter, and then had tabs on them. They're now welded to the frame. The last thing I want to talk about is how the bow in that frame was created, and we'll go over that as well. So they're coming to pick this up today. I know that I should have actually videotaped some of these things while I was doing it. I was a little pressed for time because they want to pick this thing up. So I was just kind of rushing through, but now that it's done, I've got a little time to go back and show you how it was done. The other thing was, especially on the canopy part, where I had to index it, I wasn't so sure I was going to get it right. And you know, I'm not real interested in showing you how badly I screw up on camera. So now that I was successful, I'll show you what I did. All right, be right back. So I'm going to attempt to show you the indexing problem out on the table, but it may not be very coherent. And in hindsight, I wish I would have taken a video while I was doing it, but I was in a little bit of a rush as we were trying to get this thing out. So I'm going to attempt to show you a little bit here in the actual Fusion 360 file, how it was set up, and in the process maybe give you a little better idea, a little more coherent understanding of how it was done. So here is the panel that needed to be cut out. Let me show you. Here is where it fits. It goes from this corner to this bar, and the stainless panel, the canopy, is going to cover that part of it. So drew it up in Fusion, just using some line drawings, and here's a spline down here to try and match the bow shape. Once I had that, you can see that this is, that's 52, almost 53 inches. So obviously it's bigger than we can cut on our plasma cutter. And in fact, you can't turn it in the direction so that you could do a 48, because it would hit the rails that are on the machine. So you have to turn it so that this 36 inch is in the direction. This is the 48 inch cut possibility on our machine. All right, so in order to index, I've got to find some point at which the cut will stop, and then go from that point and cut the rest of it. And so here is the first part. Um, I cut this off. Let's see what this dimension is. Uh, well, I think it's like 33. It's pretty close to the max that you're able to do. Let me edit this sketch. And let's see what that is. Yeah, right, 32.998, so 33. And as you know, in the Y direction, our machine cuts just a little bit more than 33, so that's pretty close to the max. Now, essentially, what I'm trying to do is, this is a sketch line, and we can cut a sketch line. Fusion 360, you don't actually have to have a two-dimensional drawing, or I don't have to extrude this out and make this is out of 1/8 inch, not 1/8 inch stainless, 16 gauge stainless. You don't have to actually extrude it out, etc. You can cut along the sketch line. So once this thing is on the table, and this is the path that will be cut, and these two are this is the beginning point and the end point, well, then when you index, you just need to slide the sheet and make sure that when you run your torch back and forth, these two are in line in the X direction. And so then once this is part's cut out, you pull the sheet back so that there's room to cut the rest, and then you cut then this part, which finishes up that sheet. So in this full sketch, basically what I did to cut this thing in half is I just created a line and made sure that it was at 90 degrees. And I'm not going to bother measuring here, but I broke this up into a 33-inch length and then the balance of that, and then modified by, I first cut this part out, and there's that first sketch line. And then for the second part, I modified just by taking out the rest of this part. And there's the second path. So as long as these two lines line up when you're doing the cut, then that's what you're trying to do and achieve in this indexing. For those that you use Fusion 360, I wanted to talk about how I actually set this thing up to cut. So, go into the manufacturer, and while it has a box that of essentially material or workspace, if I'm cutting out on a sketch line, I don't really need to worry about it. So came into the setup, edit, where's my edit, there it is, and did the normal things. You selected the machine, and I said, where do I want my origin? Well, I wanted it at the sketch point, and selected the sketch point down here. So that's okay. Then came to my 2D profile, edit, and here is, so I selected the tool, which in my particular case is I'm cutting stainless. So in the geometry is obviously just the outline, but in particular when you get over to the I passes in the compensation, which normally it is left, and so if I selected what it normally is left, well then it wants a in computer compensation, etc., etc. Well, I chose center. I don't want any compensation. I want it to go right along the center line of that cut path. And then so when you get over here, I zero there is no lead in, there is no lead out, and in fact there's no pierce clearance. So what's going to happen is that torch is going to start at this location and follow in the center, no compensation for curve or anything else, and cut out that outline. Now that's how I particularly did it. I'm not sure if that's the best way to do it or not, but it seemed to work pretty good, and I was happy with the result. While sitting here at the computer, the last thing I want to talk about is I mentioned in the video how the one particular part of the sign that had a lot of holes in it, and they needed to be accurate 1/4 inch diameter holes. I was not comfortable that the plasma cutter would be able to cut those out. As you know, sometimes, especially smaller holes, they're not exactly round. And so what I did is talk in the video is how I marked out where those holes were without actually cutting them with a plasma cutter, and then took them out over under the drill press and drilled them out. And the way I did that is when I brought in this sketch, this was provided to me, it was a DXF, brought it into Fusion 360, and I made sure that the origin of this point down here is at 0, 0. Then I could come into each one of these holes and select the very center, and again now you get the location of that, and I just went in a somewhat pattern and wrote down the dimensions of every one of those holes. And once I had those, then I created a file. Let's take a look at that. I created a file here. It's called Holes with Pause. And you notice that I took just the first part of a normal output of our post, again for Fusion 360, up to the point here, H0, which basically tells the machine to turn the plasma torch off. Well, when you start one of these programs, hopefully the plasma cutter is not on. But from there on, then I just hand input the location, the G0, the location of where that hole was, and then the G4 is a command where I tell it to pause for 5 seconds before moving. So it goes to this XY location, pauses for 5 seconds, goes to the next location, pauses again for 5 seconds, and etc. And then so each time that it paused, I just took my little Sharpie, and you'll see in the video, and made a point there. And that's how I located those holes and was able to drill those out on the drill press. Now, I don't remember if I talk about it in the video, but at the end, then when all these holes were done, I brought in another program, did not move the 0, 0, my work 0, and cut the profile of this here. So then I had profile cut out and all of the little holes marked on that profile, and then once it was cut out again, took it over to the drill press and drilled them out. Okay, hope that helps. Okay, let's talk about how we'll cut out the canopy, which is bigger than can fit on my table. It's 54 inches long and about 36 inches in width. So I had a piece of the stainless here. It's the stainless that's covered by a protective sheet. And so again, after we cut it out and get it in the canopy installed, and we'll peel that off and rivet it down, and we're good to go. So in the drawing, as you remember where I had the entire canopy, and I created a cut line, removed some lines. So this is just a sketch. This is a Fusion 360 sketch.
that has been turned into a cut path. So here it is on the screen. This is what it will look like. I am sitting at, move around here so you can see. I've got sitting where it started. Here you can see where the little laser spot is pretty much right on the corner of this. I don't have this exactly in where it was located when it was cut out, but imagine this was a 4x8 sheet. It was actually 4x4, but as you know, in our tables only cuts about 33 inches in the Y direction, and so it hung over on that end. So in this cut path, basically, it's going to cut and then leave. It will start here and end over here. And let's see this run. I've got it in obviously dry run, so I don't actually cut anything. Those notches there at the end I had to do afterwards, but okay, so that was the first cut, and I then brought it back to the zero. So let me, so I go to work zero. And I bring in the second part of that. And this is then the top part. And so essentially what I had to do was pull the sheet, index it, so that the top part of that was now able to cut. And I'm obviously trying to do this, real time. It took some time, and so where the points of the cut wound up, it left 2 points, and all they basically had to do was move it around and adjust it until. Let me move this. I'll bring it right back. Let me get this thing set up. I'll show you what I did. Okay, let's try this again now that I got it set up. I actually did a scale on this and reduced the cut in size a little bit so that you can actually see the cut, see the little laser spot. So there's a little difference, obviously, but I wanted to see what it looked like. So let's go ahead, and I'm going to set this to its 0 point. All right, so now what I've done is I've made sure that this point and this point lined up with where it finished the cut on the first index. And so now, let me move this over a little bit so you can see the laser spot. And now it will cut out the final part of this. Okay, so the first cut, the first indexed, the cut path ended where this now started and ended. So we've now completely cut out that canopy. So that's the indexing, and I don't know how this would be done in a different kind of CAD program. This is the way I did it in Fusion, but seemed to work out pretty good. All right, I'll bring you back now. We'll talk about the next piece. Okay, in the CAD file, you can go to the center of each hole that that's going to be cut and get the exact dimensions of where that hole is located from its reference point at 0, 0. So I actually went to each of those and had to do by hand, write down what those coordinates were. And then I created a cut file that has all of the normal stuff that's in our Langmuir post-processed file, up to a point where the H0 turns your plasma cutter, make sure it's off. And so then I just typed in the G0 with the coordinates of the first hole, and then I told it to pause for 5 seconds. Then I went to the next coordinate, pause for 5 seconds, the next coordinate, pause for 5 seconds, etc., through every one of the holes that were in that CAD drawing. So then what happens is after you get ready to set up, and I just put a piece of cardboard down here so that you can see the point of the laser, and I'll basically show you what I did. I first verified that that laser spot was actually where the jet will make the cut. But then you notice in here, I don't have to do a dry run or anything else, because in the code, it never turns it doesn't lower the torch, it doesn't do any of the THC or initial height sense kind of things. All it does is moves to that position and pauses for 5 seconds. So when I start this program, you will see. So it went for 5 seconds. I made a dot. I just took my Sharpie and I made a dot of where the laser was pointing. So, et cetera, et cetera. I'm not going to bore you with any more of that. So now that I have those points of where they're located, I cut then the perimeter using the regular cut process. I cut out the perimeter and then took it over to the drill press. Actually, made a little mark of where those were with a punch. Took it to the drill press, and I drilled those holes so that they had an exact 1/4 inch diameter hole. And they line up where they would have been if I were to have cut those. So that was my way around the problem where sometimes the torch doesn't cut out a nice circular hole, whether that's due to some kerf or whether it's due to some of the bevel that's inherent in these plasma jet processes. And our table, I know there's some tables that do very accurate holes, but they're quite a bit more expensive than what we have in our Langmuir, which does a great job. So that's how I cut those holes. The last thing I want to talk about is how I made the bow in the 1 inch square tube. All right, I'll bring you back. So the bending of the bow on that frame was done with a simple Harbor Freight tubing bender, but I have done the Swag Off-Road mod to that, which includes adding welding on these wing extensions, and then installing this hydraulic jack modification, and then building or modifying or adding this drive roller that uses then the Harbor Freight threading kit power, which I already had. And then the Swag Off-Road does offer some dies for that 1 inch. They've got a full set of dies. If you know me, I'm cheap, so I actually just turned those. I have a lathe, so I turned those out of some, I think I had some 3-inch diameter steel. So I made those on the lathe and installed those. And it worked actually very well. It was pretty easy to do. Now, I'm not going to bend this piece of tubing because I want to continue to use it, but you can, let me turn it the other way. And you just simply turn the jack, and it puts pressure on this roller and begins your bow. The Harbor Freight comes with basically a hand screw up in here, but you need a lot of pressure, and that hydraulic jack just makes it so sweet. I don't know whether, how much of a bow you can put in 1 inch before you start getting some kinks. I didn't need much, but this is capable with using the right dies and so forth. I think you could roll a complete ring of certainly solid bar and, round or something like that. But it worked great. I was happy to get some good use out of that. And so that's how I did the bow. So I think that's it. Just give you again an idea of what we created and basically the 3 things that were a bit of a challenge for me and what I did to try and get around them. Okay, thanks for watching.